I'd like to introduce the last speaker in the session, Dr. Kun-Pei Lin from National Taiwan University Hospital. The title of his talk is Analysis of Plasma MicroRNAs as Biomarkers of Dynapenia in Older Adult. So let's welcome Dr. Lin.
Thank you, Professor Lin and Professor Alai. It is my honor to be here and present this topic. Our study is the analysis of plasma microRNAs as a biomarker for Dynapenia in older adults. Dynapenia, most people know sarcopenia, but Dynapenia is very important too. We will introduce the Dynapenia according the phenomenon and the definition and the characteristic of the Dynapenia. And because Dynapenia and the sarcopenia are very similar, and they share the same symptoms and the same signs, so we will introduce the distinction between these two diseases. And the third, the impact of the Dynapenia on overall health and the functional abilities in older adults. Dynapenia, the definition of Dynapenia is the age-associated loss of muscle strength and the predominance caused by non-specific conditions. In other words, if patients with specific disease such as the stroke or muscle damage, neural damage, we can say they may be caused by the secondary factor or secondary cause. And the characteristics of Dynapenia is the same or similar to the sarcopenia. It has a slowness, weakness, and a low physical performance. However, there is currently no agrees upon the algorithm to diagnose Dynapenia. These two charts illustrate how Dynapenia is influenced by the age. In the left chart, the red lines represent the muscle mass, and the blue lines represent the muscle strength. We can see the red line, the muscle mass is declined later than the blue lines. So the muscle strength decline is occurred early than the muscle mass. As the age, the right pictures is show the data is from the South America. We can see in different age group, the prevalence of Dynapenia is also different. In the people with 50s, the prevalence of Dynapenia is about 17%. When the people consider they are older, if they in 70s, the Dynapenia prevalence becomes approximately 30%. So this indicates the Dynapenia prevalence is higher than all adults. This slide shows the distinction between the Dynapenia and the sarcopenia. The main difference between Dynapenia and the sarcopenia lies in muscle mass. Dynapenia typically refers to a functional decline, and this means the blue area. The blue area shows a decreased muscle strength, and the gray area shows a decrease in muscle mass. Their combined zones, the dark gray area, is the sarcopenia. So we can say sarcopenia is equal to the decreased muscle strength, Dynapenia, and the decreased muscle mass. However, the age loss of muscle strength is weakly associated with the loss of muscle mass. For example, if the patient with weight gain also had muscle strength decrease, but their muscle mass still increase. So, when our focus is the muscle strength or muscle functions, consider the sarcopenia may be not specific. Dynapenia may be the more, when we focus on the muscle function or focus on the muscle strength, Dynapenia may be a better target. Dynapenia also has impacts for overall health. First, it will increase the risk of physical disability and poor physical performance. The people with Dynapenia also increase risk of falls. maybe they have weakness or slowness or bad or worse environments that they increase the force. And though they also have more risk of impaired metabolic health, such as hypertension, diabetes, or hyperlipidemia. Because muscle and bone have a very close relationship, so the Dynapenia, patient with Dynapenia also has higher risk of low bone density. Some studies also indicate that Dynapenia has correlations with cognition function. And because the Dynapenia makes people's weakness, so they also reduce quality of life. And overall, we had found the Dynapenia had increased mortality in the elderly. Several biomarkers in Dynapenia have been described. The most described biomarker is the MicroRNA, specific on the muscle, specific MicroRNA. And some inflammation markers had been demonstrated in previous studies, such as CRP or the ESR. Some proteins like insulin-like growth factor or myostatin has also been found. Cortisol and testosterone, these endocrine markers also be found in some of the Dynapenia cases. However, most biomarkers are uncertain and ongoing research may identify additional markers to refine the significance of existing ones. This slide shows the microRNAs, how the microRNAs functions in our physiology. The message RNA produced by the typical gene and proceeds the synthesis of protein. However, microRNA acts on the message RNA and leading to the degradation of the target. That will inhibit the protein synthesis or then block the protein assembly. This slide shows the postulated mechanisms pertaining to microRNA function and the Dynapenia. When people become aging, there are physical changes that occur at the cellular level, such as mitochondrial dysfunction, chronic inflammation, metabolic dysfunction, cell apoptosis, resistance increase. They were found associated with microRNA's regulation. These factors may lead to the Dynapenia. And patients with Dynapenia also lead to the physical inactivity and they may have insufficient nutrition. Both of these two conditions may worsen the physiology change. So it became a virtuous cycle. So the microRNAs plays a certain role in the physiological change. So this is our studies methodology. We will select the patients from our OPD and the demographic information will be collected. Then the plasma samples will be collected and processing. The identification and the quantifications of specific microRNA will be done. This is our study flow chart. We enroll patients aged older than 65 years old and who visit our geriatric OPD. Some will be excluded, including the unwilling or the total dependence like bedridden status or the cancer patient or disease terminal case because their function or their prognosis was different from the community ones, and who are incapable to be evaluated because we need some evaluate tools. So if they have total hearing impairment or vision impairments, they cannot proceed this evaluation. The sixth, patient with stroke or neurodegeneration disease will be excluded because, as I mentioned above, patient with specific disease
leads to the muscle weakness or neural damage, they may consider as a secondary effect, not the pure Dynapenia. And these patients will be tested physical and functions performance, and measure the body composition and collect the biomarker, including the microRNA. We will do the age and sex match compare. And finally, we found the normal group about the 38%, and the Dynapenia group is about the 34%. They all for the prepared sample and for the microRNA analysis. Our study's criteria for Dynapenia definition is for the two criteria. Criteria one is the grip strength. In men, if they had less than 28 kilometer. In women, if she had less than 18 kilometer, was considered a lower grip strength. As for the walk speed, we use the 6 meters walk test. If they were tested lower than 1 meters per second, they were considered as a low walk speed. If patients meet the criteria 1 or 2, will consider the Dynapenia. These criteria were set based on the Asian working group for sarcopenia. When they collect the plasma, the chromosome for microRNAs, we will check the total RNA extraction and the small RNA library preparation. And then the size collection, and we will do the most important step, the next generation sequencing. After the next generation sequencing, we will perform clarity and read the filtering. Adapter remove filtering against other RNA species and annotations against human reference genomes. And at final, may find the novel microRNA discovery. This is our sample process summary. Also, we had 72 participant samples curated, but there were 2 samples because of poor RNA quality was closed, and there was 9 samples because of poor sequencing quality was excluded. So as the final, they had a total of 61 samples was collected for the downstream analysis. The right table is the simple demographics analysis. Because we had age and sex match as the first, but so the age and the sex statistically was showed not significant. We also performed other disease or other functional evaluations, but not shown in this table. The other disease like the diabetes or hyperlipidemia, hypertension was not significant in our study. Why we chose the next generation sequencing? It has 3 advantages. First is high throughput. NGS allows the simultaneous analysis for hundreds to millions of sequences, providing high throughput data generation and compatible for the comprehensive microRNAs coding. 2, it has a very high sensitivity. NGS can detect low abundance microRNA, offering high sensitivity for the discovery of rare or low expressed microRNA. So if the microRNA was at the very low level and the distribution to very right, we can find it. And 3, NGS provides a comprehensive analysis of microRNA, not limited to the species known microRNA. We don't need to review hundreds of papers and to find previous studies chosen RNA. We perform a total complete microRNA analysis. That will enable the discovery of normal microRNAs and assess of overall microRNAs expression patterns. This is our result. The principal component analysis reveals plasma microRNAs difference between the Dynapenia and the control samples. In this principal component analysis, we can see the distribution of the two principal components, PC1 and PC2. There are still some difference in the distribution of the blue dots. Blue dots represent the control group, and the pink dots represent the case group. So these two groups has significant difference distribution. These pictures show the differential expressed microRNAs between Dynapenia and the control samples. The left table is volcano plot. The volcano plot highlights statistically significant difference in the microRNA. The x-axis represents the expression difference of microRNA. The further to the left or the further to the right means the greater of the difference. While the y-axis represents the statistically significance. Typically, if there were more upper zone, they have more significance in the study. So, when we show, we can observe the blue dots as upper left. It means the negative correlation to the Dynapenia. And the right and the pink dot in the right upper zone, it shows a positive correlation to the Dynapenia. And the right picture is the heat map. Everyone knows heat map is a very good visual presentation for the ORNAs expression. We can find the blue is the control group and the case group is the pink. The lower expressions is the blue, purple area, and the red areas means is the higher expression. We can see the two areas had separate clearly. We employed the 10 microRNAs in predicting Dynapenia. It's focusing on the selective positive features. The heat map on the left illustration demonstrates their distributions. Meanwhile, the right chart shows AUC curve, shows AUC area for the predicting Dynapenia and reaching a promising value, 0.77. We use another 13 microRNAs in predicting the Dynapenia, focusing on the selecting the negative features. The heat map on the left illustrates their better distribution. We can see the purple, blue, and the red area separate very clearly. Meanwhile, the right chart shows the AUC for the predicting Dynapenia, reaching a SN values 0.82. So the combination of supposition and negative features for prediction. We combine the positive and the negative model and combine them to a composition model. The AUC was about the 0.81. This is our future direction. In these studies, we identified a total of 10 microRNAs possibly, and the 13 microRNAs negatively correlate to the Dynapenia. And this microRNAs will be composition to a compound of microRNAs model. We would use them maybe to develop validation model in the future, or the verifications through the in vitro microRNAs mimic transaction. This is our conclusion and the future direction. We're using the NGS for microRNAs research. We suppose the NGS is a very good tool, especially in the complex or multifactorial disease, such as Dynapenia, Sarcopenia, or frailty. They can provide a deeper understanding to this condition or disease. And our studies identifies approximately the 23 microRNAs associated with Dynapenia, and observing they has a classical effects in certain specific regulation mechanism. This may provide additional reference data for future research on Dynapenia, Sarcopenia. The last, currently because there is no clear diagnosis or treatment or management guideline for Dynapenia, and we want everyone to get more attention to this condition because Sarcopenia, as I described above, the muscle mass will decrease later, become the muscle strength decline is early than the muscle mass loss. So Dynapenia will be found earlier than Sarcopenia. So if we had more tools to detect or screen the Dynapenia, it may prevent these patients become to the Sarcopenia. So our findings maybe give us screen tools in the future. Okay. This is the future directions later we may be performed. The identified microRNA and their sequence in vitro synthesis of microRNA maybe we give the mimics or the inhibitor, and the transaction to the microRNA to the in vitro cells. We want to maybe the muscle cells is the more suitable because Dynapenia or Sarcopenia may occur more specifically in the muscle cell. And the screen shows difference in the expression the pro-inflammation cytokines, like the interleukin 6 and TNF-alpha. Factors in protein degradation is also interesting mechanism. The factors in mitosis pathways may be the next topic. And then we will reconfirm the results by microRNA inhibitor in vital cell model. So this is my speak. Thank you for everyone.